Thank you to the organizing committee and to BD for this invitation, which I'm happy to receive. And I would like to show you a recorded case of an innovative endovascular technology creating AV fistula. This is my disclosure. So we're talking about the wavelength endo-AVF system, and this is the French version. The patient arm at the beginning is placed on a dedicated carbon arm board, and the distal forearm is exposed optimally by hyperextension of the wrist so that you can puncture the distal vessels easily. Choose a room setup you feel comfortable with and which allows you to use simultaneously the C-arm and the ultrasound system. Check the access site and the venous outflow, and compressing the vein helps to find the right place to puncture. In this case, we puncture the ulnar vein first, and it helps if the cooperator checks the appearance of blood at the micropuncture needle so that you can focus on the ultrasound examination and puncturing the vessel. Arterial puncture is done nearly in the same way under ultrasound control, and again it helps a lot if the cooperator checks the appearance of blood at the needle. Then we inject diluted contrast medium to check out the arterial system. Here you see the check of the venous system, and unfortunately the wire went into the medial ulnar vein, what we didn't want. So we had to cross over to the lateral ulnar vein by using small bridges which are allowing to cross over with the guiding catheter from the medial ulnar vein to the lateral vein, and so to the designated anastomotic creation site. On the left picture, you do see this in magnification, that we used one of the small bridges to cross over with the wire and then with the guiding catheter. Placing the wire into the medial ulnar vein leads to a wire crossing twice, so we couldn't achieve a proper alignment. In situations where you can't align catheters properly, you might use the perforating vein and the venous outflow tract to place the venous catheter if those vessels are suitable for this maneuver. Navigating the venous wire through the perforating vein into the outflow tract facilitates a catheter position near to the perforator. The arterial guide wire gives you orientation to navigate the venous wire into the correct position. We mark the position of the perforating vein with a needle, and using an arteriogram and venogram allows a precise placement of the catheter system. Here you see the wires in place before advancing the catheter, and the venous wire is placed in the outflow tract into the cephalic vein. We always advance the venous catheter carefully into perfect position by using the valve crosser so that the electrode isn't damaged by this maneuver. We are checking the perfect alignment of the catheters by rotating the C-arm so that we can get a perfect perpendicular view of the catheters in place. And after that, we just apply a 60-watt radiofrequency pulse, which is delivered for 0.7 seconds, so that the electrode cuts from the venous to the arterial site. You can see the situation post-activation, where there is no gap between the electrode and the ceramic backstop. Coil is placed into the deep brachial vein above the elbow to direct the flow to the superficial system. The completion angiography by gentle injection via the arterial sheath shows the jelly bean appearance of the anastomotic site and no residual flows observed within the coiled brachial vein. Achieving hemostasis by using a standard radial compression device. We know it's all about flow, so we always check the result post-intervention by ultrasound. Thank you very much. It's great to be part of the meeting.